Now, having got this, let us head on to prove some identities. Students, we are going to be using the double angle to prove some important identities. Now, the first question is, we are asked to prove sine 6x over 1 positive cos 6x is equal to tan 3x. Now, what I wish to do is, I would like to write this. Foremost, let me just consider the left hand side. So that's going to be sine 6x divided by 1 positive cos 6x. Now, I wish to write sine 6x as sine 2 times of 3x divided by 1 positive cos 2 times of 3x, right? So clearly you can see that we can easily apply sine 2 theta formula and cos 2 theta formula. Let me write that down. Since sine 2 theta is 2 times sine theta cos theta, and cos 2 theta is equal to 2 times cos squared theta negative 1. I am specifically using this formula for cos 2 theta. So if I were to substitute them, this is going to give me, assume that theta is taken to be as 3x, right? So visualizing that, write the formula. So this is going to be 2 times of sine theta, so sine 3x times cos theta, so cos 3x, divided by 1 positive of cos 2 theta is 2 times cos squared 3x negative 1. So removing the parenthesis, this is going to be equal to 2 times of sine 3x times cos 3x divided by 1 positive 2 times of cos squared 3x negative 1. Positive 1 negative 1 gets cancelled, and that would give me 2 times of sine 3x times cos 3x divided by 2 times of cos squared 3x. 2 can be cancelled. A cos and a cos 3x can be cancelled, giving me sine 3x divided by cos 3x, which is tan 3x, which is right hand side, hence proved, right? You see that? And that is the end for this particular question. We are asked to prove this question, students. Cot x negative tan x is equal to 4 times cos squared x negative 2 divided by sine 2x. Now in this case you can either use the left hand side or you can use the right hand side, so depending upon your choice. So what I wish to do is I would start with the left hand side. So consider the left hand side. It's going to be a little bit lengthier if we use the left hand side, but if we were to use the right hand side, the solution would be quicker. Probably, let me just try both sides. So consider the right hand side. Right hand side is 4 times cos squared x negative 2 divided by sine 2x. So if I were to take 2 out, this is going to be 2 times cos squared x negative 1 divided by sine 2x. Now 2 times cos squared x negative 1, that's going to be cos 2x, and you have a 2 there, and you got sine 2x here, right? Cos 2x, if I were to write it as cos squared x negative sine squared x divided by sine 2x. So I'm just moving on right from here, right? So assume that there isn't any strike. So this is equal to 2 times of cos squared x negative sine squared x divided by sine 2x is going to be 2 times sine x cos x. So 2 gets cancelled. Now you got a negative b divided by c. I can rewrite this as a over c negative b over c, right? The algebraic property. So from that, this is going to be cos squared x divided by sin x cos x. So a cos and a cos gets cancelled, followed by sin squared x divided by sin x cos x. Sine gets cancelled. So this is giving me cos x divided by sin x negative sin x divided by cos x. Cos x over sin x is cot x. Sin x over cos x is tan x, which is nothing but the left hand side, hence proved, right? So that is actually taking the right hand side. Now let us consider the left hand side, okay, which is, this is cot actually, right? This is cot. So cot x negative tan x, this is what has been given. So let me take this as cos x over sin x and tan x as sin x over cos x. Now if I were to take the LCM as sin x cos x, this is going to give me cos squared x, this is going to give me sin squared x. Cos squared x negative sin squared x is cos 2x divided by sin x over cos x. Now what I wish to do is I would like to multiply the numerator by 2 and divide by 2. So 2 times cos 2x, I'm just retaining it as it is. So cos 2x, now I would like to write cos 2x as 2 times of cos squared x negative 1, and I have 2 times sin x cos x. So 2 times sin x cos x is nothing but sin 2x. So this is equal to 2 into 2 gives me 4 times cos squared x negative 2 divided by sin 2x, which is equal to right hand side, hence proved, right? So I have actually taken two sides, both the sides, and I've shown you the proof. It's up to you. You don't have to use both the sides. It's just sufficient enough that you focus on one side and extract the solution to the question. So this is all about using double angle identity